So now we excavate the tunnel, and then for that is zone relax excavate command. And let's see if I used any parameters there. Step, yeah. So I used step parameter here and 1,000, meaning that I will excavate gradually over next 1,000 steps, which is very slow. Typically for this model, it got to convergence within like 40 steps or 50 steps. And I will reduce the tunnel properties over 1,000 steps gradually until they basically go to very small value, and then I remove it completely. But I need to specify what to excavate. So range, group, tunnel. And then I need to solve again. Model solve. That's pretty much the whole thing I need to do for this model. Make sure I didn't miss anything else. I used convergence here, but doesn't really need it. I can say model solve. After that, I just need to save model, save. That's all. Again, this is a small model. I can rerun it completely. If I don't want to rerun it, I can just select these lines and press this button here. For shortcut, Control-Shift-E. I can press Control-Shift-E and rerun this. So let's go back to stresses and let's see how they're going to change. All right. By the way, if you double click on the saved state, it will restore it. Remember, I clicked back on geometry, it will restore that geometry save state. I can click on the initial, it restored that initial save state. That's where I see where I was when I saved it. Let's hide this GP fixity plot item. And let's make a few changes here in the interface so I can track multiple things at the time when I excavate. I'm going to hide these commands just to make more area for me. And I'm going to create a couple new plots. I'm going to create new plot to track. Let's see, I think I was tracking displacement. I was tracking history of displacement and history of unbalanced force. Let me show that that's exactly what I was. No, I was tracking displacement, plasticity, unbalanced force, and that top part, or this was a displacement of the roof. So how to do that? Basically, I'm going to create a couple more plots. So let's call this state. I'm going to track plastic state. I'm going to add, again, zone. And by default, it selects label groups, so it shows just groups, my groups. I'm going to select here state. It's going to show me plastic state for each zone. And plastic state basically means if the plastic limit was exceeded and zones are failing plastically. So right now, nothing is failing. In this initial state, everything is elastic. The stresses didn't exceed my shear limits or tension limits. So I'm also going to create a couple new plots for histories. Let's say first unbalanced force. Or actually, let's first say displacement, because we're going to track displacement first. It really doesn't matter. You can arrange them. I'm going to call it this. And from here, I could go to whole list of plot items, but I can add history chart here. And you remember we have two histories. We specified that we're going to track unbalanced force and displacement. So I'm going to add this by pressing on the plus button. I'm going to add displacement to this plot. And that's my initial displacement. One thing I could add in the plot, I could reset displacements, initial displacements. So remember, they're actually meaningless right now. Especially after excavation. So we created this initial stable state. And from that stable state, I want to track displacements. So what I'm going to say here, I'm going to say even before modeling relax, I'm going to do this zone initialize displacement to 0, 0, 0. I'm basically resetting displacements because I want to track them during the excavation only. I don't care about this initial displacement that was present there during equilibrium calculations. That doesn't mean that we reset the model completely. Velocity, strengths, and stresses are still there. So this is my displacement. Let's create one more plot for unbalanced force. This one we're going to call unbalanced force. And again, I'm going to add history here. And I'm going to add mechanical unbalanced force. So this one we don't need to reset. You see, it converged, basically went from some high unbalanced force pretty much to 0. Very close to 0. Now let's just arrange this plot item so I can easily see how things change. I'm going to split this view in couple. Actually, first I'm going to split it horizontally. Split horizontally, and this one I'm going to split, and this one I'm going to split. Now I can track 4 plots simultaneously. You see how I did it? I clicked here, split above or below. That was the first thing that I did. And then each of these views I split also. So for the first one, I'm going to show stresses. Actually, let's select stress right now. Then I'm going to show state. For this one, I'm going to show history of displacement. And for this one, I'm going to show unbalanced force. The only thing I wanted to do here, I wanted to change stresses to displacements, so contours of displacements. So for the first plot, instead of stresses, I'm going to select displacements here and the displacement magnitude. You see the legends are really small. It's really just because of resolution of the screen. They will become bigger on bigger resolution, but I could also change the size of the font here. You can just go to legend and say what you want to change here in this legend, for example, contour size. You see it starts appearing here as well. I'm just showing you so you know that these things can be easily edited. You can play later with this. For now, what we're here about is only just to look how things change in time. All right, so we got these 4 plots. Let's track how things gonna change when we excavate that tunnel. So I'm gonna select last 4 lines of code here and execute only them. And that's gonna be a relatively fast process. Right on here. I didn't even initialize displacement on displacement is on grid point. On grid point initialize. So now I'm going to execute these 4 lines, and you see, oh, that's it. Ran really fast. We see we got deformation. This tunnel under gravity got squeezed. We got plastic failures here around the tunnel, and we can see that it's failed in the past during this process of excavation in shear around the tunnel, and the top part failed in tension. Let's see if anything is failing right now. So this index P means that it's failed in the past. We can turn it off, that index P, by saying no past over here. And currently it's back in elastic. So we exceeded plastic limits, but when essentially we equilibrated everything and completely removed the tunnel, things So stresses under the plastic moved to under the plastic limit. And that's how my displacement of the top of the tunnel changed. So it's negative displacement, meaning that it's moved down. And then you see it's kind of little oscillation here, and then it equilibrated. And now it's stable at this level. And you can see here, maximum displacement is about 4. Obviously, it's huge value. It's probably 4 meters. This tunnel will not be built in practice. And this is how my unbalanced force changed. So this initial thing was calculation to equilibrium, this initial conditions. Then I started reducing the properties by, weakening the properties of the tunnel and reducing the stresses. And that's why we have jump, then things started equilibrating, and then suddenly I removed the whole tunnel completely. I just removed those zones, and things went unbalanced. And then the final balancing happened here. So that's the idea of this example.